imagine this event being more originally of a lot of outsiders coming in to like want to know about what's going on, but actually we have more insiders here, so it might actually just be like a joint venture type sharing information scenario. Our chain gets to sort of present what they're doing to EXA and sort of vice versa. Does that make sense, Ed? Did you hear me?
I heard some of it. You were saying something at the end I didn't quite catch about collaboration scenarios, something maybe more Q&A or more just conversational as opposed to presentation.
Yeah, I think it could be that actually.
Yeah,
you guys up for that? Does that make sense?
Conversation.
Okay.
I do have my time is somewhat limited, so I'll go through the kind of the slides really quickly. Also, we may be joined at 7 o'clock here. Lawrence Lerner, who's doing business development and marketing for our team as well. So he can, carry on the conversation too. Should I just launch in, Nathan?
Yeah.
Okay, awesome. Well, much better to see more people instead of the back of the laptop. For coming out tonight and great seeing you all. So I'm Ed Eichel. I'm the CEO of Archain Holdings, and I'm one of the founders of the Archain Cooperative, as well as the board director for Archain Cooperative. I'll explain what those two organizations are and how they relate. So I'm going to do slides, and we've been collaborating with Nathan for, I don't know, it's been 5 months or more, maybe even 7 or 8 months. Nathan put together the video that's on our homepage. So I'll share a few slides. Would like to leave lots of time for conversation, so I'm going to go through these fairly quickly, and I'm happy to come back to the conversation. Are you able to see my slides? Okay, great. So our key value propositions of Archain is that we're building a whole blockchain platform that is scalable and trustworthy to make those claims as we go on. I'm going to assume some familiarity with blockchains. Otherwise, you may not be attracted to come to the meetup tonight. But as we all believe that blockchains are going to reshape how the economy works. This is not just a new technology. It's not just an experiment. But this is really going to be revolutionary in a lot of ways and change many industries and works. The opportunity that blockchains provide us as innovators, as investors, and on our outlook of life and society is sort of a kind of a multi-decade kind of thing. If you look back over the early web was created and the amount of initial confusion, the anticipation of good applications and ecosystem and the bubble that followed in the late 90s and the dot-com bust, but some survived, right? And so many great things of the web and internet. And of course the internet was intended to be a decentralized for commerce and for sharing of information around the world. It's become more and more centralized. So blockchain helps build what I call a trust layer over the internet.
Ed, do you mind if I interrupt you a little bit and when we're familiar with this model, maybe we can dive deep into why is Ethereum centralized?
Well, I wouldn't call Ethereum centralized, but let me just keep going. Okay,
yeah,
I'm going to go faster. So Ethereum has some challenges. This is Vitalik at DevCon 2 last fall. Has issues with privacy, scalability, cost, latency, and Ethereum and all the blockchain projects are working to issues, as well as new startups creating brand new blockchains. Just to kind of set the position of our chain relative to Ethereum and Bitcoin, 40,000 transactions a second. We're pretty confident we're going to get there. We are implementing proof of stake. Just signed on Vlad Zamfir as our director of the R-Chain Cooperative, and as well as working with R-Chain. Vlad and our co-founder and inventor Greg Meredith has been working Casper and proof of stake for 2 years now. That's not a secret, but it's not necessarily well known either. We are going to have a concurrent model. Similar to Ethereum, we're programmably complete or Turing. R-Chain will also have content delivery, and we'll have, of course, our tokens. The primary one after its launch is called the REV, R-E-V. It's launched. We have a ERC20 token called the ROC, R-H-O-C, and Chain Cooperative is actually just in the process of wrapping up a membership drive and a private token sale of the ROC to its membership a couple hours from now. If I look a little frazzled, it's because I've been in the middle of that. So how can we make these claims? We're driving the R-Chain platform of mathematics around concurrent processes, obviously around cryptography, and also around game theory. The stake protocol is essentially a type of game theory to drive consensus. And the mathematics around the concurrent processes and the specifics are called pi calculus and rho calculus, are really quite a big driver of why we make the claim of scalability, and I'll get into that. I was mentioning the cooperative and the holding company and the private sale that we've got going on. There's a tight relationship between the R-Chain Holdings Company and the cooperative, and the mission of the cooperative is to build out the platform. It's a membership for the benefit of its members. The members will make the major governance decisions. And then the holding company is an incubator that will foster startups and joint ventures and projects and is a for-profit company. And so we're looking for opportunities there. The cooperative is also looking for developers, platform developers that understand functional programming, new programming language, and that have an appreciation and want to learn more about formal semantics. A specialized breed that is needed for the architecture looks something like this, that an R-Chain node will run on the Java virtual machine. It will have its own execution environment for written in Golang, and there'll be different layers of that as shown. We're in the process of building that out. We have the programming language specification, the Lightning database in the storage model, and for initially the same communication model as Ethereum runs, this RLEX, I understand. And so some of the initial plumbing is working already. There's a draft programming language spec. There's a virtual machine that's running. There's the compiler between them. But there's also a lot of work in front of us. Protocol is specified at some level, but there's quite a bit of work to finish that. We're about 6 months away from an alpha. We'll be able to demonstrate, pretty high transaction volume and consensus across many nodes about 1 year from launch, and we're calling that launch the Mercury release. In terms of what will be built on top, just about every blockchain solution you can imagine. Get many of the proof of concepts that are being built both by developers as well as enterprise organizations. They're really across the whole board of innovation, and they're waiting for scalable blockchain or Ethereum to fix their scalability issues. So this is just a long list of potential things that can be built. But the holding company will especially encourage initially applications to really foster this ecosystem. So already we're working and identity solutions, but we'll either go on to partner with those, building those, as well as these other initial applications like timestamping services, private messaging, content delivery, name registration, and what I call a personal blockchain. And I'm actually going to pause here because that's the primary content, and go as deep technically as this group would like to in terms of our mathematics and what makes it scalable and so forth. So happy to take questions at this moment.
I'm going to record a bit of this.
Oh, we should probably say casting this on a Hangout on air. So if I've got no releases or nothing like too formal with anybody, is that not okay with anybody? Okay with everybody? Okay, if that changes, tell me.
So Nathan, if there's anything for me, I'll need you to repeat it.
Yeah, I'll start with a question. So this is, I think, a collaborative question. So what about Erlang's concurrency relates to X's concurrency? So you're calling it fabric, but it's I think it's very similar here. So the concurrent model. So yeah, you guys have both expressed to me that you're building concurrent platforms. Yours is calling it, theirs is fabric. I'm a little uncertain exactly how the concurrency model is established. I know it's through the use of the ladle algorithm, but maybe you can go into that a little bit.
Sure thing. So concurrency happens at several parts of the system and the protocols. At the level of the virtual machine, in contrast this to the Ethereum virtual machine, which is sequential at the VM level. So this is really a key aspect of the mathematics driving this, is that the categories called mobile process calculating is all about processes running concurrently and interacting in a way that, and the mobile part of it is that the channels over which the processes are communicating or interacting may be changing. The topology of the network may be changing. So it has a really good applicability to decentralized systems. And so the programming language Erlang is a direct mapping of that calculus. And the programming language itself is concurrent, and the virtual machine is concurrent. So at a given node level, if there's dual quad core or whatever the local machine is, it will take advantage of all the processors. And then when we look at concurrency, for example, the consensus protocol would work, is to not over-constrain it. So thinking back at a user level, if I have a transaction in Seattle to buy something with the red token, and you have a transaction in New York to buy something else, they don't need to go through the same consensus algorithm unless they're involving the same vendor addresses or the same payer addresses. And this is where it gets a bit difficult for me to explain exactly how we can make those claims. But let me extend a bit about the node topology and what the blockchain shape looks like overall. So as you all know, that both Bitcoin and Ethereum, all the transactions around the world are put into blocks and are essentially sequentialized or stacked on one blockchain. So all the nodes have the blockchain does is it relaxes that constraint, and it allows different nodes to care about different sets of transactions and contracts, smart contracts, or programs more generally. And it does that through the use of namespaces. And namespaces are a traditional computer science thing. You can think of it similar to a URL or a path that's hierarchical, where you can address a particular name by its path, or vice versa. A name is given context based on its path. But with this high calculus, it doesn't have to be just a tree and have a name live only in one namespace. A name can actually live in multiple sets of expressions, which is also another aspect of namespaces. So going back to nodes is a node then can be configured to care about a particular set of contracts, a particular set of user accounts, and then only care about the interactions with those accounts. And as long as there is enough validators in the consensus cycles so that the double spend is prevented and given the surety of the redundancy that's needed in the blockchain, that will all scale. And then, most of New York's transactions and most of Seattle's transactions can truly be independent of each other. And then occasionally there'll be some that aren't, and those will go through a different level of consensus, requiring nodes that care for a particular address and contract about both of those things. So that's the simple way that I think about how our chain will scale, and we're still working through both explaining this as well as building it, but the mathematics support it very directly.
You guys have a follow-up about that?
So with that concurrency model, and like your data structure isn't a series of blocks where each block is a list of sequential transactions. Maybe I missed this, but can you talk in a high-level way about what sort of the actual data structure is? Are you still calling it a blockchain? Are you not?
Did you hear that? So he's wondering how we can call it a blockchain if it's not sequential or series transactions.
Exactly. I appreciate the question. And in a sense, there's some aspects of our chain that aren't a blockchain in the data structure sense. In similar to Ethereum, there's a tree structure, TRIE, in terms of serializing what's on a node, and from a transaction perspective, it looks more like a graph actually. And it's not. I don't think it's even a directed acyclic graph. It's a more general graph, and these things can be independent of each other for sections of the blockchain. So our chain is not precisely a blockchain in the sense of Bitcoin and Ethereum in technical ways. In that data structure way where you're allowing this concurrency and relative independence. But there's another way as well, which is in our chain, the storage will actually be leased. So, some transactions will be kept in the system for a long time because of the redundancy that's needed and the eventual finality as you go through the consensus. But especially for larger content, its place in the blockchain will require a deposit that will create a lease agreement with the protocol. So unlike other blockchains that have this guarantee of immutability that once it's on the blockchain, it will never change, or that storage will never change, our chain actually won't make that guarantee unless it's paid for. So this is another way in which the our chain will actually scale. Because there again, it's a great, interesting promise, but it's not free, right? It's actually quite a burden on Ethereum and our Bitcoin nodes to not only run all the transactions around the world, but keep all of them forever.
So who would pay for that lease?
So it'll be paid for upfront, actually, during the transaction. So some small part of the fee will will go to that storage component, that lease, and who will reap the benefit of that will be the node operators that will prove they're storing that data over time.
So how does that relate to, Corbett, maybe you want to weigh in here, how does that relate in terms of your concurrent fabric model?
Well, I wanted to see how deep a question I could ask, but would you say like each VM is incorporating event loops with each other VM, or is there a different concurrency model? It's more granular. Yeah.
I understood part of that. You were talking about how VMs communicate, and I didn't understand the whole sentence. Sorry.
Before we go into these data structures, blockchain-like data structures, what's the concurrency model that each VM, that each node in the network follows in order to coordinate state transitions?
So like a state channel with Lightning?
I want to know.
Yeah, I understood the essence of the question. It's actually a challenging technical question for me personally to answer, but let me just give you a flavor of it. This is exactly the mathematics of concurrent processes, where the VMs at a particular time are evaluating a particular contract or a program. The program may have a dependency on another program that's not even necessarily on its own node. So it needs to pass a message or a transaction to another contract. And whether it's on the same VM or a separate VM, the same thing is happening, where all of these interactions are asynchronous. There's a call out. The calling contract will essentially go to sleep. In other words, its state will be serialized and stored on the blockchain as its next state. The other contract will receive that call essentially asynchronously. It'll wake up, run that transaction. That transaction may be a callback to the first, and then the first one will wake back up and continue. So the notion of a transaction in our chain is much more granular, involving all of the messages between programs, not simply the transactions that are initiated from the user or the account. Does that give you some flavor?
It does. It does. So, in order for VMs to start participating on a contract or something that initiates those transactions, they need to become aware of each other. What is the security model? What is it that enables them to know, hey, this VM is authorized to communicate with this other VM? Is it like permissionless? Is it permission? What's the security model?
Yeah, I actually don't know how to answer that one. So let me make sure I'll paraphrase the question and see if I heard. What is the security model between contracts or programs? How do they know about each other? How can they call each other? They find each other through namespace resolution, and the nodes can be configured such that they have permissions over, which namespaces they even listen to or care about, so that even with the same software, with some configuration, you can say this node is truly a public blockchain or a public node. It can be open to any of these namespaces. Or even with that, you can say, but it doesn't want to take on namespaces that require gigabytes of storage, or for news, short movies, and music, for example. Not to want to work in that. It only wants to work with very small financial transactions, as an example. So the nodes declare what namespaces or what qualities of namespaces they care about. And inside of a corporate setting or a consortium setting, it may be very restrictive to say these nodes only want to listen to these certain IP addresses and only these namespaces, so that it can be tightened down in that way. At least that's my understanding of the initial design.
Okay, we're talking public blockchain first, and then tightening through ACL line permission systems for permission.
Yes. So our goal is that it's the same architecture, and it's just configuration through access control lists and et cetera for tightening it down.
Most of my questions are highly technical.
That's good. Go ahead.
Hey, my time's getting a bit tight. I've got a lot of demands with this membership drive and private token sale. So let's maybe just take one more question.
Yeah, that's fine.
I want to know what's going on with the you're wrapping it up. Like, what's the how did you do it?
I didn't hear the question.
Like
Sorry.
with your membership drive, like what kind of
Oh, that's awesome. Yeah, so we've been having this membership drive and private token sale for about 3.5 weeks now. We've closed and completely closed about $5.5, and that's taken in a combination of Ether, Bitcoin, and a little bit of US dollars. We're still pulling, the submissions and requests from today. And we have a number of people we've yet to follow up on. It's been, and in terms of membership numbers, we have at least 300 members, or 250 to 300 members total, and a large chunk of that amount has come in the last several weeks, and so that's awesome. Yeah. The R-Chain Cooperative is a membership-driven organization, so having that group of folks that care about the future of blockchains is really important to us and our decisions in the future. In terms of the fundraising, we still have yet to close several of our rock purchasers, and our individuals also that are coming back sort of a second time as they realize the opportunities. So someone that maybe started 3 weeks ago at $50,000, sometimes they're coming back for another $50,000, et cetera. So it's really exciting. It's a bit crazy, frankly, but it's a good crazy.
Yeah, hey, that sounds great. Congratulations. That's a great result.
Oh, thank you so much. I've really enjoyed meeting with you. I was out at this space at the end of May, and would love to come out to Pencilworks soon again.
Cool. When can those of us that don't have $50,000 buy some membership stakes? Is there going to be like a smaller?
Ed, when can people who aren't accredited investors get in on the crowd sale?
Yeah, I need to run, but we don't have a locked-in crowd sale. I expect that it's likely that rocks will be listed on an exchange, although that's kind of up to the exchanges. The co-op's not pushing that. The launch of the R-Chain platform is approximately a year from now, when we'll convert or redeem the rock token for the Rev token. And certainly at that time, if not before, Revs will be, at that time, Rev will be on an exchange. But I think there's going to be opportunities much earlier.
Okay, guys, great. Thanks so much for your time, Ed.
Thank you.
Yeah.
Sure.
Bye.
All right, we're gonna transition now that we've sort of burgeoned our population. Hey, Kevin, what's up?
Really quickly, Rock are available on Oasis, Dex, and Ether Delta. If folks want to go out here.
So you can pick that up. To get on Ether Delta, it's not a really intuitive interface, which is kind of sucks for most people, but yeah. So we're gonna transition into EXA and network. So we're gonna take a moment of tech setup time, and then we'll dive into this thing.
If you don't mind, whoever just said that?
That was Kevin.
Hey, Kevin.
He's over there now.
If you don't mind, could you maybe give us a little bit more details on how we could do that?
It's on the GitHub.
It's on the GitHub.
On Archain's GitHub.
Okay.
Yeah, I listed it out.
Okay, awesome.
I know it's
It's under the issues.
Okay,
I
got it.
don't know what the issue number is, but it's on there.
What's the other issue other than Ether Delta?
Oasis.
I'll find it and then I'll reply to the
They're
meetup.
they're
Did
currently
you respond to the meetup?
Sorry, what's that?
I'll find it and I'll
they're
Next
they're-
video.
No, it's 30.
They have 1 more hour to go in a sale that has a $50,000 minimum.
Here.
Oh yeah, let's go. Excellent.
No, I'm not good.
Yeah, so it's fine. I think the idea, were we supposed to do a little networking or something between the two and then
Yeah.
get going at 7:30, or did you
yeah,
want
it's
to do
sort of
sooner?
loose. Yeah, it's kind of loose.
We can say some hellos.
Yeah, you guys can.
Maybe we'll get to know each other a
Chris,
little
do
bit.
you
Like,
wanna
go
run
around the room just so we know who's here. And this is a nice, intimate space that we have. Thanks again to Pencilwork for doing this, and Nathan. This space is awesome.
Hey, very well, thanks.
It's become quite a blockchain hub, so it's really special to be able to do this here. Thank you so much for everyone that's here. I think we're in rare air. I mean, we just heard from what could be the next big smart contract platform, and I think I believe we're about to hear from even the next one, and what these guys and girls are putting together is global, it's powerful, it's passionate, and what really stands out to me about we're going to hear about incredible technology. Just one thing I wanted to say that really stands out to me about EXA and about Gravity is that they really think about right and wrong and about creating a better world, and that's what's going behind the architecture of the platform. So I personally, I've got a finance background and economics degree from Northwestern. I was in investment banking and private equity, and I said sayonara about a year and a half ago to focus on the well-being space, and I help incubate platform-oriented well-being companies, and now I'm raising capital for a coaching company to help people improve their quality of life, because God knows we work too hard. So that's me. My name's Chris.
So maybe if what I'd like to propose is for us to introduce ourselves in 3 words.
Perfect.
That'd be good, yeah?
Yeah.
So I'm Vienna, also from the economics-based agency. So 3 words that really is compassion, AI, and distributed system.
3 words. John Miller.
Okay, maybe we'll go to Daza.
Great. Hi, I'm Daza Greenwood. 3 words. Let's see. Puppies, law, innovation.
Mathematician, philosopher, alien.
Kind of stole mine, so I'll have to do like kind of like synonyms. Let's go with ontology, cyberpunk, and AI.
We're gonna go everyone.
Chip Foley from Friends and Family, 3 words, or New England Life Sciences.
My name is Jason Cicero, the head of training at Block Apps. We're out in another part of we're in the other part of Williamsburg. 3 words: humanity, economics, and innovation.
So Eric Rue, I'm pretty new to this. That's not how we work. Disruption, wealth management, and global.
Dick Bryan from Sydney University. Marxism, disruption, and free-floating anxiety is a high value word.
Grant. I work in real estate. I'm interested in 3 words that are land, justice, and neophytes.
I'm Brendan O'Weir. I'm working with Sustainability Internet and distribution, cognition, and intuition. Those questions.
Suzanne Foley. I'm not knowledgeable about any of this, but I'm curious and interested.
I'm Khalil from Japan. I'm working for the Japanese media, innovation, technology, and
Retire, ride, and investor.
Okay, so my name is Kathy Henderson. I'm a coastal engineer, and my 3 words are climate change, horses, and
My name's Corey Levinson. Usually I'm not in New York. I live in Berlin, but I'm here now, and you all are here now, so I came. 3 words for me. I would say I'm a developer, mathematician / data scientist, and musician.
My name is Eric, based in Montreal, cultural theorist, art, philosophy, and activism. I'm Scott. I'm a self-taught engineer, environmental activist, troublemaker. I like making vegan snacks using a 3D printer that I invented that's powered by bicycle. And 3 words. Sustainable futurism is a hyphenated word. Appropriate technologies is a hyphenated word. And specialist.
I'm James, software developer, JavaScript, and trust.
I'm Axeli from the Exec group, also 3 words, okay, so open source finance.
All right.
Nice.
I'm Jorge, also it's a group. 3 words: trust, compassion, agency.
I'm Pekko, Peksa. Break the 3 words for me. Okay, I'll try. You, me, and the pure joy of semantic meta operation.
Multi-hyphen.
Pure joy of semantic meta operations.
I'm Anya, also Lexa. So, future of humanity, economics, data science.
So for those who just came, we are putting a little game. Try to describe yourself in 3 words. So, try.
Hey, so my name's Kevin. I'm a evangelist at the IOTA Foundation, doing business development strategy. And 3 words will be beyond blockchain.
Oh, okay. I think it was 2 of them then. Sorry.
I'm Eric, and 3 words to describe me are engineer, machine learning, and vegan.
Great.
My name is Christian. I'm an archivist.
Great. And review. Have we gone to you?
My name's Kevin. I work at a IP commercialization firm called QBank, and I don't know what I heard 3 words. I'm not sure what the 3 words was supposed to describe. If it's me, concerned with my family, friends, food.
In that order.
We've got some great seats up here, so you don't have to stand if you don't want to. What time is it now?
You can start a bit early.
Yeah.
Tweak the world that we're starting early at no additional charge. Well, can you guys speak up for the meager mic?
Right. Maybe just check in everybody. How are you guys doing?
Yeah.
Okay, good. Okay. Maybe a round of applause.
Yeah, what, your words? Did you say? You didn't say it. Your word. You did.
Compassion,
Okay.
AI, and distributed system.
Start. So, okay. What's going to happen is I'll just give a very brief, like, it's not even an introduction, but kind of I pass the ball to Jorge with our main course. So Jorge is the software architect and designer, creator of Gravity, and we want to spend today the most of the time there. We had a really nice event yesterday at ePlux. There was a lot of it was a full house, a lot of people, and we were there concentrating a little bit more on the social, political, and technological, economical sides of what we're doing. And here we would like to concentrate on the technology side, which means really Gravity. So that's the number one thing. So the second important thing is that we are here we're thinking that this event, we are here like just among friends. We're not trying to pitch or sell anything because we're not ready for that either. So we are just, it's like a little bit like a special moment. We've been really working hard with the team to get the token launch ready. We are almost there, but not quite. So this is like a special moment to peek a little bit behind the curtains, what is going on, and yeah, that's like the attitude what we were talking, like how we would like to approach it. So we are a little bit also testing some things, our communication, the messaging, and any ideas, feedback. That would be like really great. And I thought that I would just quickly run through what is going on at the moment. So with the team, just like a 5-minute. So as said, so we are Economic Space Agency, and it's really important to understand that. This morning I was thinking about what I should have said yesterday. And yeah, one of the things really is that it's important to understand that it's not a metaphor. It's not metaphor, but we are really thinking that like Ed was saying also in the beginning, that the new network technologies, they will potentially produce a radically different economy. And what Economic Space Agency is trying to do, we're trying to give people, create and build the tools for people to start exploring and operating this new economic space. Give agency to people into this new economic space. That's what it is in its most simple form, at least to me. So with the team, we've been really, we have a distributed team. Basically, the headquarters are, we came from Oakland. We have a house and a garage in Oakland. The team lives in the house and works in the garage and a little bit elsewhere too. It's pretty intensive. But the garage door is always open. You're really welcome to come and join. There are a lot of people are hanging around just in the garage yeah. It's hard work, but fun too. Yeah, but we are distributed, so we have some core team members also in Finland, here in New York, Washington, Berlin, Rio de Janeiro, Athens, Greece, So that's we're distributed already, and we work like a virtually, and it functions pretty well. Montreal, also Philadelphia. Yeah. So with the team, we've been now working really hard on getting like a token launch or token generation event ready, and it has meant like 5 things, and I'll just quickly run you through. So number one has been that we've been really working on the building credibility around the technology, the gravity, and the claim that we are making. So one of the key things is the white paper. So the white paper is not yet publicly out. We have an internal version, and we are working on it. Jorge was just locked away for 2 weeks to get the technical documentation, design documentation ready, and it's working, I think. Do we need to lock you back there? I don't know. I don't know. But so we are adding the technical specification to the white paper. The narrative is there, and we are. If there are people who would like to review, take a first look, just let us know. But it's looking very promising. We're working. One of our key advisors is Mark S. Miller, who is, I don't know if you know, he's one of the old crypto gods. Really important to smart contracts, like as important as Nick Szabo and Satoshi Nakamoto, I think. And with his good friend and his technical writer Bill Tullo, so they're helping us with the white paper, and it's yeah. So it's coming together, but it's not public yet, and we're getting there. Then we had one really good event in San Francisco like a month ago with Mark Miller. He was there. Nick Zuko Wilcox, Brian Warner from Tahoe Labs, Arthur Brightman from Tezos, kind of where it was called Blockchain Meets Object Capabilities. And we are hopefully with the white paper organizing other events. So basically that means that we're like gathering some of the key technical singular people around us, reviewing the white paper, and kind of giving it legitimacy, basically. Then the second thing we've been working on that we just like, I don't know if how many of you followed the Sunero and Archain drama. I think it was super exciting. I was watching like this 4-hour meetings in the hangouts with all the drama going on, and I must say that Ed and the Archain team really handled it really well. They really got my respect through that process, and for them it worked also really well. They started to like just to their weekly meetings. They were in hangouts like transparently, publicly, and suddenly you see that there was more and more every week, a little bit more people like this community building. Both that's one of the reasons why we're here too. So we're hoping with Chris and Jonathan, we have some really good base here in New York that we could have a meetup and people interested in joining the project and becoming involved. So we are planning to have a big, good hub here in the East Coast too. That's one. Then we've been meeting here with our advisors and econauts. We have Jonathan, Ben, Dick, some really good people here, like who I respect a lot, and we are consolidating their support. Brian Masumi, Erin Manning were here yesterday. Some other really, really important people, but people who I respect and I like a lot. We've been having meetings with them. But we're trying to consolidate our close advisors and collaborators around us at the moment. Then the events. We only this week, we are here in New York. Vienna was at MIT. We had a team in Macau, in China, Hong Kong, London. So we're like getting out to the certain events a little bit so that people would also know that we exist. So that's the second thing. Then the third thing we've been working on is like key messaging. Just like Ed said, it's not so easy to message about this, and we've been like really trying things out and We have like failed like badly most of the time, but we are also getting there. There are some. This is something what we would like to test today. So at the moment, what do you think? So the key slogan is gravity, deep interoperability for our decentralized future. Yeah.
That's exciting proposal.
Okay. What? Okay, so but I think it's pretty good. I think it's pretty good. Well, we have other candidates too, like smart contracts, unchained. It's pretty catchy. Let's see. But okay, that's one thing. And yeah, how do you get the messaging and communication and like right? It's hard, but also really interesting work. So we've been working on that, and one important things. So we have like, how do we message about this like post-blockchain or this technology which is taking it beyond blockchain? How do you talk about it? That's one thing. Then the team, which is another part of key part of the messaging for us is, and that's easier. So we are really, and we've been explicitly building the team to from the learnings from the Bell telephone laboratories, Xerox PARC from the 70s, like how they built these teams where there were like people from different areas of expertise, like sociologists, computer scientists, software architects, economists, finance theorists, because we need to like bring the expertise, and everybody needs to like overcome their own comfort zones and step out into this new emerging space, because we need everybody there to create it. So this is how we've been building it, and that's part of the messaging also that we are like the Xerox PARC of the 21st century, distributed version of what they were able to do. Yeah. Yes. Then just like Ed was saying, it's really interesting the diagram he had about how their TG or the token launch, how did they call it? I can't remember now, but kind of how it's structured. Also, like in legally with the cooperative and the holding company. So we've been designing the actual structure of the token generation event. So we have different organizations. We have we have just set up the foundation in Switzerland in the Swiss Crypto Valley with MME, which is the same legal council that originally set up Ethereum, and now recently Bezos and Polen, Infinity, a lot of different foundations like operating on the protocol level. So that's set up there now. Then and it's a really good team. I like their team a lot. Just in fact, and we're gonna talk about that. Today I had a call with Lowell Ness from Perkins Coie, who is our legal counsel here in the US. Really interesting call about how to deal with the US situation at the moment, and how they've been talking with SEC about certain things. So it's really interesting. Also, like how do you design it in a way that because things are changing continuously. So we've been really working on the token economy design, the legal design, like what is the structure and how it plays out. Then we've been working on finding the right like the distribution channels. So this is what Ed also mentioned there. Kind of we are thinking that we want to build an ecosystem, not only the protocol, not only like a product, but an ecosystem, and it's a different logic. It's a different logic. How you need to do it. We need a wide distribution, which fosters the healthy ecosystem. And what we've seen before, like this far, how many people are taking part in the token sales, I think it's really ridiculous. Like it's from 800 to 3,000. Even the big sales are like 10,000 people. It's like ridiculously small amount. So we're looking forward to much wider distribution, maybe 100,000 people. So how do you pull that through? We are cooperating with, for instance, Blockfolio, which is one of these really good apps. I like it too. So they're hoping to turn the Blockfolio app into a ICO, kind of a token launch platform, and they would like to offer our token to all their users. And they have more than 600,000 active users at the moment. So I think that will be a major, could be an important play. We were with the eFlux yesterday. eFlux is also, I think, important. Different audience opens a different channel to reach a lot of really smart people who are maybe not so familiar with the crypto world. And the last thing is we've been designing the fundraising, and we are just about to start the early contributor period for our close networks and strategic contributors, which basically means that we want to bring our people who we trust and who have already trusted us close to us, and we want to give them the most favorable deal at the moment. There are now already some momentum and some more traditional monies lining up, but we would not like to take it first in. Then the second layer of the onion, how we are thinking about it, is that we are looking for this really particular kind of people who understand the importance of creating this kind of cyber-social infrastructure for the future. This fundamental technology development project. It's not we're not looking for the speculators, but kind of for people who would like to, who consciously want something like this to be built. It's a long-term, like a commitment, and this is the group we want to reach. And then there are some singular investors with whom we are talking, and I'm thinking that we are bringing maybe 1 to 3 of them on board when the time is right. And here we are.
So yes, my name is Jorge Lopez, and I want to invite you personally to, why I'm here is precisely because I want to share with you guys what the project is about, and I think it has enough technical beef to engage with credibility with a highly technical audience. So I want to get an idea of, in the room, who of you consider yourselves like highly technical, like concurrency models, data structures and stuff, just to get a sense of where I need to go. The other, who else in the room knows enough about blockchain, its implications, models, why they're important and whatnot. So everyone else, all right. Yeah? But then I need to do that. So I'm going to meet you guys in the middle. Most of the talk opens highly technical questions that I'm happy to resolve, but I'll sprinkle around a lot of why are we taking those technical decisions, right? So what are our design goals regarding it? We want ability, safety, privacy, scalability, and security. Privacy is particularly important for what we're trying to do. Most of the offerings that we're seeing either are fully open, fully self-funded, fully transparent, and therefore their structures and the platform is public, but also visible to everyone, which leaves outside the element of privacy of these platforms, or falls in the other spectrum, which is neutral technologies, no economy of its own, that are mostly funded by private corporations, and because they don't have the constraint of the token as funding model, they have more freedom of movement in terms of how is it that they design their platform to allow for privacy permission blockchains and whatnot. By separating very, very clearly each concern into layers, I think we're able to accomplish the best of both worlds. So I'll go into talking about that. Is that better? All right. Actually, like that. So what are our design principles? And we apply this both the microkernel all the way to the building of the network. It's extreme modularity. Why do I mean by extreme modularity? We already understand that modularity is good, allows for separation of concerns, allows for testable code, and in the terms of blockchains, allows us for small pieces that are more easy to verify, and both formally and just to review. But it has another angle, which is security. Who is familiar here with the object capability model? All right. So in the object capability model, extreme modularity is taken to extreme by following what is known as the principle of least authority. Basically, each agent, each node grants another agent or module even only as much authority as it needs in order to perform its function. What this allows us to do is both design software that is resistant or more resistant to attack by virtue of reducing the surface area of its APIs, what it makes public, but also internally makes less buggy software, particularly in concurrent systems or distributed systems, which is very important, by virtue of reducing opportunities for even unintentional destructive interference among components. So, authority is privilege, super important. And another one, reflectivity. So we go to great lengths to make sure that the whole platform in every layer is reflected. That means that it can introspect in itself, change itself, update itself, heal itself. So that means that we are bringing in a lot of the lessons and the philosophies of reflective language like JavaScript, but really the grandfathers, Smalltalk, Self, and whatnot. So what makes Gravity's approach distinct? So we see blockchains not only as linked list, not as an atomic thing that is, but we see them as a subset of a much wider taxonomy of distributed verifiable data structures. When seen in that way, when deconstructed in that way, it really allows us to look at the field differently, in which we no longer need to bias our minds towards logical centralization, and we can also decentralize the logical layer while still bringing in full consistency across the network. So the role of verifiable data structures is really the role to preserve the integrity of the state. We extend this further to also preserve the integrity, of course, the computation by encoding computation in the same data structures as all reflective languages do. Access control, following object capabilities, principle of least authority, and messaging by virtue of having reliable computation, be able to create reliable messaging. So what this allows us to do is, it allows us to shift from verifiable state, where most blockchains are focusing on, into verifiable state to stateful protocols. So really we're overusing state in our current solution space, in which our approach to concurrency, coordination, collaboration, cooperation among different processes is a post-it board in which everyone puts their notes and everyone is able to see who put them, verify that they haven't been modified or they've been there. Everyone's looking at them all the time. And this is a poor replacement, really, for good protocol design, for reliable protocols. there's reasons for that we inherit from the design motivations for Bitcoin, which needed to be like a state-resistant distributed ledger system, and we've been carrying them through as unnecessary design constraints. So we need to start like seeing, being discerning, where is it that such design decisions need to be made, and what is actually justifying them. So we need to understand the threat model of our distributed application and be able to see that different applications have different requirements. There's totally useful applications for something like architecture like Bitcoin for more than Bitcoin, and there's such a large landscape of verifiable applications and really trustworthy applications, more like it, that need to be enabled, that the current platforms are really leaving out by virtue of over-relying on state. But there's a reason for this. Obviously, solutions like Corda, like what Corda is proposing, they are not over-relying on state. Actually, they are more protocol-centric, but the reason they can do that, again, is because they don't have to protect their token. So for other solutions, the whole monolithic blockchain approach is really incentivized by virtue of wanting to preserve the value of the token, the network built on top of this architecture, but the design principles of the token become the design constraints of whatever you build it from. So we've taken the approach of not having those incentives at this layer. So there's no native token in the microkernel as itself, although you can build such things on top. We built then a microkernel that allows us to create a verifiable virtual machine, which allows us to verify execution, state transitions, and access control. From that, we can create networks of verifiable VMs by virtue of being able to have reliable protocols among them. And with that, logically decentralized applications that are still trustworthy and fully verifiable in different dimensions instead of just one blockchain. And a means of bringing acidity, that means atomic, consistent, isolated, and durable transactions. We do distributed transaction protocol, two-phase protocol sharding. However, all at the top, Gravity is trying to enable these things. It's not trying to bake them in. So Gravity is highly protocol-centric. So we go beyond, right, to create resilient multi-party protocols. Most of the protocols that we have today assume either one-to-one or like just broadcasts. But how do you create secure, reliable, stateful multi-party protocols? Well, that's Gravity's goal. So hopefully this conversation is bringing questions. Questions and answers are going to come at the end. Feel free to ask any layer of detail. So deconstructing consensus. When you have the capacity to create reliable, stateful protocols, you can start breaking consensus apart. And this might get a little bit too technical, but this is what really gets me excited. And if there's a word, I'm happy to describe them. But we can deconstruct consensus into like message ordering, for instance. How do you solve the problem of message ordering, right? And there's this concept of event queue circuits that can be done with these multi-party, reliable multi-party protocols. We can check the execution integrity by having, again, computation verification circuits, and state transition integrity, having state verification circuits. For those that are familiar with concurrency, our concurrency model is cooperating event loops among verifiable agents, and this is how we are able to do this across different elements of an application. A Gravity application is really a Gravity network of applications, microservices, each one reliably servicing the others in a fully verifiable way. So the end goal is to create a global, open, decentralized, scalable, and high-performance trusted execution environment that supports privacy. So.
Yeah, how does this relate to the ecosystem of Polkadot?
Well, I'm not an expert in Polkadot. I haven't been reading papers for the last 6 months. Okay. But I do keep an eye.
They basically classified like a bunch of different actors to sort of filter out who is the one giving the consensus.
One of the first things that I was that.
I can kind of answer that one. Like basically, like my understanding of Polkadot from when I've done the white paper is like, they're doing something very similar to us, except we're doing it at the level of computation and not data structure. So we're like hashing the state transitions of the state of the program itself, and not state transitions on like a data structure. So like the way that it does like auditing and verifying minors and whatnot. It's very similar to what we're doing, but we're doing it at the level of computational state.
Which is faster or more secure?
More flexible, I would say.
More flexible. I don't know if there's like a much difference in speed, but like we're doing it at the level of generalized computation. So it's not just smart contracts or blockchains. It's any program you would want to run on a distributed cloud fabric.
And there's questions I ask whenever I skim over these papers is, are they talking about economic groups, proof of stake, proof of whatever it is that is not fundamental, basically, which is stopping their coin? And then I know that brings incentives for certain architectures that I'm precisely trying to get away from because I know where they live. And the other one is, do they mention, again, the coin, right? And if they're talking about like ledgers or transactions or financial instruments, I just go like, all right, next one, right? Because I know that space, and there's a lot of development, and I think there's lots of application for specialization at that state. But using a state for solving the double spend problem, right, which is nothing else than reliable execution, and building on top of using state as the only way of bringing about reliable execution, I think it's taking things into a direction that is very constraining for what you can build, right? Unnecessarily so. If instead you focus on creating reliable execution on the bottom, you don't need a proof of stake and you don't need whatever it is that people are proposing proof of stake.
So then why not operate on a private database?
What do you mean?
I mean, like reliable execution happens in a private database. So what's the
Well, from reliable execution to even locally, where you don't trust your own hardware, like the microkernel doesn't trust its own hardware, and all the way to distributed execution, precisely by making sure. And in this one, we might need to go very technical of how is it that if you don't play according to the protocol, you can't keep participating. So is the incentive is in there to keep playing according to the protocol. Has to do with event queues, verifiable event queues, message ordering, verifiable computation, utilizing replication, for instance, to make sure that nodes are not trying to lie, right? But the basics of it is many of the same principles that are being utilized by blockchain. We're still utilizing them. We're just like utilizing them in like more granular way and more like composable.
Come on.
A similar question to Archie was, can you talk about what the data structure is, or like what the data side of all of this is?
Yeah. Each virtual machine,
What's the data side,
since it's
data
a
structure?
virtual machine, you have what is known as your local object reference graph. You have your root scope, which is like namespace really, which internally inside of the runtime has a root scope chain, a scope chain, and from there you can create the closures, you create your variables, you have your mutable state and whatnot. So if you look at this data structure from the top, what do you see? A tree, right? So if you want to, scopes are inherently immutable, right? Only their variables, the values change, but not the structure. At least it's one of the rules that many of these programming languages code. By allowing within Gravity itself to hash your references, sign your references, encrypt your objects at that low level, what you can create is these verifiable distributed data structures, where each reference to another object that has been marked immutable has in the metadata the hash of the object that it references. But what it means is you can have any data structure that can be created with objects that still has the same verifiable immutability semantics than blockchains do, but not only for linked lists. It's any structure. We include also functionality of signing, being able to sign your references, and being able to encrypt your objects.
What are like the primitive transactions or actions?
So at the low level, transactional computing it's a protocol, right? It's basically, if you have, let's say, two phases to it, basically, the VM, the microkernel is here transactional. You send a message, everything is message sending. You send a message to your microservices, which is running like a simulated trusted secure environment, because the whole system has been bootstrapped to verify the hash of every element that it executes, precisely to make sure that the data integrity of that encodes the computation has not been compromised. But forgot the question. Sorry, I got the data structure.
Well, the first, I was asking about transactions. What are
Two-phase commit protocols. Okay. So these microservers can be made transactional through protocol by doing something like, here's message, here's a continuation, because everything has to convert eventually lambda calculus in order to have a more like pi calculus in the system for concurrent processes. And the VM sends a message out saying, this is a proposal. This is my state change. Here's a write, a continuation for you to commit, or a write to rollback. Just with those element blocks, you can create networks of these transactional microservices, and through protocol, through coordination, they can come up with reliable state transitions among themselves. But again, that's something you build at the next layer, which is our holy grail, by the way, distributed color precisely.
Okay, just then like a final sort of follow-up on this thread. So would you say then that the idea of like coins and wallets as like primitives actually aren't part of this equation at all, but they're rather something that would get built on top by independent
double spending is
nothing.
Protecting double spending is nothing else than doing verifiable computation, verifiable state transitions. You want to make sure that the truth is preserved, right? That means that the system integrity is preserved. So we go low level, we get rid of all these roadblocks and do whatever we can to preserve state integrity and computation integrity, not only among one microservice, but networks of microservices. This is where object capabilities come handy too, because these microservices may only be communicating with each other through either introduction, creation, or initial conditions, right? So embedded into that is already a security model also. Like things that are not introduced are like dynamically impossible to find each other, right? So they cannot guess where they are. So that's the principle of object capability.
Could you speak to the use case of, the purpose of the token, given that you mentioned, there are purposes for proof of stake and the constraints that they build and the differences with Gravity?
So Gravity is trying to enable a future where not only you have like the main technologies or the main network issuing tokens, but when everything and everyone is an issuer of whatever, right? And it's trying to tokens, financial instruments, assets, truths, doesn't matter. And to enable those like millions or billions even of transactions, we need to first of all, logically decentralize. So you cannot keep thinking in terms of blockchain. You need to still maintain system-wide computational integrity. That's why we go to that length to create these verifiable data structures, separating concerns, permissioning. This is a verifier. The only thing it can do is verify. This one is a data state transition verifier. This one executes a redundant computation to catch up any recent events. All of those microservices have been isolated in such a way to allow us precisely to preserve state integrity, to also detect state integrity violations. Instead of using economic logics or incentives to direct behavior or disincentivize behavior of these nodes, basically, if you play by the rules, you keep playing. If you don't play by the rules, you just can't continue in the play, right? Because everyone can tell. This basically shifting to message strings, what right now we're keeping a state, like for instance with message queue circuits, when you have like a per message definite order in how the message arrives, what you can do is allow every node in the queue to be able to receive incoming messages. When you have like the whole transition of the messages on all of the nodes, which by the way doesn't have to be linear, they can crisscross. You can say like when 3 of my previous nodes confirm a 4, I forward to the next 4 nodes in this channel. And when it completes the end loop, basically, or when receive it back from the other side, I consider it queued, right? But you need to be able to reliably create that protocol, that setup, right? Then you'll have message ordering on a per event basis. So there is no need to block them or have like funny leader selection algorithms. It's done through protocol, through collaboration. So there was one point about economic incentives that I wanted to make. So by not needing the token and instead relying on protocol, and the incentive to play is the incentive to use the protocol, right? Like if you're using the protocol, it's because you want to use the protocol. And also, as microservice can have like 5 nodes, 500,000 nodes, but centrally, so 500 nodes, but certainly I cannot think of a microservice that could need 100,000 nodes, for instance. There's wasteful, right? So oh yeah, now I remember. So in the message stream, each message also refers the previously approved message in the hash, right? So you have in there, you have like a blockchain, but it's a message stream. So this is part of bringing what right now is seen as state, as protocol. You can actually project a protocol into blockchain. When you see that the blockchain is a message string that is retrospectively verifiable and retrospectively joinable, right? So, but it's really it's a buffer. What's going on in there, right? Did I answer your question?
So I was wondering, are you planning to create some kind of a token standard like ERC20 as a way to ensure that there is the state integrity?
I'm sure that's going to emerge. This is not where my mind is.
So you're thinking maybe somebody will build like a token standard on top of it as an application?
Well, there's this other platform that the Economic Space Agency, this other project that is incubated by the Economic Space Agency, which is called SPACE. And SPACE is precisely as an economy. It's not a currency, it's an economy. So it has distributed exchange network distributed network offers, economic spaces, which is inherently allows people to issue, self-governance, voting, all that sort of stuff is still on top, right? But to really create this fully decentralized fabric, right, when there's not one chain to rule them all, you need to go all the way down to protocols. That's the last decentralization boundary.
Also, another answer to that is if you're interested in that aspect, Techco, right there, is the person to talk to.
I'm giving space to
Yeah.
Harry.
So yeah.
We have space here.
If you could just take it up one level, I'm trying to understand. So how are you then incentivizing peers to see the network one day for
Well, that talks also about our next project, right? Like,
how are you incentivizing the
network?
network?
First economic space that we're launching is called the Warp. The Warp is precisely a global, distributed, trusted execute environment where basically what you get is a virtual machine that you can do whatever you want with. But it's private. It's your data. You control it. It runs there. You don't know, right? But it's reliable and it's elastic and whatnot. I mean, it all comes down to protocol. There's a lot of work to do, like to build another for those who are technically inclined. The programming philosophy of these protocols, where at the higher layers of abstraction, the programming languages you can build on top of Gravity, allows the creation of what they're called like IO-free protocols, where even message buffers are objects. And what that allows you to do is recreate protocol reusable components. So obviously part of what our effort towards building space and the work is creating a collection, a library of these protocols. But what we want to create again is this global namespace with lots of utility stuff, and not only that, an economic space with an economic logic that incentivizes developers to keep contributing into the economy, but also users to provide their data. So both users and developers monetize on the information. In Gravity, in the Gravity network, the work, information is mass, right? That's why it's Gravity. And that's what gives value to the network. And I have to say it's related information, interconnected information.
Just going off of that. Mm-hmm. So for the case as a user, so today I go on Facebook or I use Google Chrome and they track my data, then they sell my identity to marketers. And is what you're saying that in the future you're talking about I would own my data and you would help me monetize it?
Yes, and we don't want to raise red flags yet in regards to that, but yeah, you can do that. And that's the end goal. Is not only data self-sovereignty, but it's preservation of privacy, right? Like you share your data according to the rules of the contract that you share it. Like if you are sharing your, I don't know, medical results for your insurance company because of a claim, that doesn't mean you give access to your whole history. And it's like a conflict of interest, right, between your doctor and your insurance company. Their job is to distribute risk, not to, like cherry pick. And that's one model in which like that privacy preservation and sharing your contacts, when you can reliably verify, again, because it's a reliable execution fabric, that you only get to share as much as needed for XY process, and after that is forgotten, right? So you can enforce deletion of data. You can enforce disconnection. You can enforce revocation of capabilities. It's all derived from being able to construct and synthesize a extended trusted execution environment. Yes, you need to go like lower level, and you don't need to worry only about double spending. It's like all this other stuff comes from free.
So is Gravity like kind of run on like different code nodes, or like
different what?
Like the different nodes, like you have to spin off for example, like a Bitcoin or Ethereum node. And do you have to also spin off like a Gravity node? And if so, would the node have to like contain like all the data structures and also all the verification that the Gravity has, or is there kind of like some kind of a sharding effect, where you have like a bunch of code nodes that contains like portions of Gravity?
Yeah, there's no concept of full node in Gravity because there's no central state. But what you have is a bunch of nodes that have either a open initial state that you have full privilege over, that you can constrain and modify over time and get to share capability with other nodes, replicate contracts collaboratively with other nodes, or you can simply install the work contract, right? In which you are a node that speaks the work protocol paid into like this distributed execution environment according to its rules, which are fully dynamic. It's not something that you just can bake into one machine ahead of time. And or you can make special nodes in which you say like, hey node, the only thing you can ever run is this microservice, and that's the only thing it does. It cannot evolve, because again, the capacity to create new environments, new trusted environments, the capacity to persist to this, the capacity to communicate with network, they're all capabilities. So you can constrain it as much as you want. If you want to learn more about this security model, you can go to erights.org. It's a treasure trove of public capabilities. And it's heavily influential. The whole thing, E as a language, is heavily influential on this paradigm.
So, there's dynamic rules, we're saying, among these nodes. So, I'm guessing you're working with some kind of probability model or models?
No, what I mean by dynamic rules.
Guessing you're working with a probability model.
Are you JavaScript developer?
Yeah.
Are you? All right. It's how can I explain this? Each VM is capable of modifying itself, right? So as a developer, I can go and create new rules. Then I get to share these rules with other nodes, right? But there's rules that generate rules. The same way there's code that generates code, right? So this all comes about by virtue of the language itself and the whole VM to being fully reflective. So what I mean by dynamic rules is that you can, ahead of time, determine what is going to be running on this virtual machine. That's kind of the point. Because once you have the node, you want the network to keep evolving. Right? From the developer's perspective, and with the programming languages, they look to them as they're writing contracts or they're writing programs. The thing they know is that they're going to reliably execute. So one example, for instance, for reliable execution that you guys are familiar, for instance, is a replicated virtual machine. Like here, if I install my contract in this replicated virtual machine, I can trust that it's going to execute correctly. But when you have constructed this more basic rules that is all about preserving the integrity of everything, every message you do, every state transition that you do, you can then derive or you can even formally prove that your programs can only run reliably, right? Because they're building themselves in these atoms, right? These base assumptions. Pi calculus comes in multi-partition times.
I had a question, or just sort of like throwing out there that since you have sort of like that base there, how then could you possibly run like AI-based DAO on Gravity?
Well, organizations are inherent. DAOs are forms of organizations. Organizations are made of protocols, right? So they are just programs, and if you want to create a microservice that runs an AI program, just like define very clear what its boundaries, its inputs and its outputs, and it will be able to speak with the rest of the network. At the border of each microservice, however, there is an object-capable protocol. Basically, every microservice, even within these microservices, everything is an object, right? So you're always talking to objects. So that's why at the programming language level, you're just doing an object-oriented programming.
Maybe to make that clear, what we're basically talking about is that because at least in our MVP, we were using the secure version of JavaScript called secure ECMAScript. So what that effectively enables is that instead of having to be like solidly a programmer, any regular JavaScript developer can write a program on it because we are constraining it with certain principles. So even from the very beginning, you are already thinking security from the ground up.
You can always hook up external services over the state interoperability is important. But then you are outside of the trusted execution zone, and that's something that the other nodes can know and take into account when interacting with AI or whatever. It's off network.
And perhaps this is where will be able to see if we made any logic like slip, like, and not have to have bugs that we don't even know ahead of time. So that could be much more secure, reliable way to achieve that. Smart contract.
So if anyone wants to talk after this, more like technical stuff like like distributed verifiable state and how that's accomplished, because that's the core. If you can do distributed verifiable state, everything else comes naturally.
I don't even want to add to this. It's such an amazing presentation. That was it.
Doesn't want it to end. Speak to the vision, higher level. What's the vision?
But now I need to talk a little bit about myself. What got me in this track and pursuing these goals was the fact that I'm from Mexico, and Mexico, as many Latin American countries, is known to be highly corrupted. And because of that corruption, among many other problems, almost every 6 years, you can guarantee that the peso is going to depreciate, right? Because issuance, corruption on the peso, unpaid loans, like loans that were never meant to be paid, that the government officials spend themselves and whatnot. So I started thinking of how is it that we can create a distributed monetary system that is end currency, right? And perhaps, as ambitious say, like end currency, but with a global unit of account that is not controlled by anyone. And in order to accomplish that, if I'm serious about that, I cannot just create like a Facebook or whatever. It has to be something lower level. So the thing that our organizational government structures were never meant to scale to the point where they are right now. And one of the side effects of that need to scale but not being designed for such a thing is that integrity loss, is internal system corruption. So to fix that, you have to relieve those social structures because they just can't. I cannot see a way in which a human operated legal and financial and economic system could ever sustain what we really are capable of doing. And we need to go like super low level into how do you present system integrity in order to be able to enable different structures. So at the same time, I don't claim to know which one is the right economic system, the right financial system, or the right governance system. But I know what the problem any proposal will have. So what I want to focus on, what I've been focusing, is in giving everyone a first start for all these proposals, for them to be able to incorporate, to influence each other, to copy each other, to evolve, to adapt into what is going to become, whatever it is, the substrate of how humanity organizes.
Can you talk about, you said, I don't know what the right system that emerges there from looks like, but I'm going to give, I want to give them all this kind of interoperable capability with these wonderful features. Can you talk about implications to the degree you can see for the big, well, what you're talking about, the big distribution problems, distribution of resources, goods and services, decision-making authority,
Or the design implications for some of the big issues that are foreseeable.
even legitimate coercive capacity.
Yeah, one of the side effects is we will obsolete the need to the threat of force as a way to bring in order to our systems. So vision that doesn't rely on us being scared of each other at the state. I mean, that already opens a design space that is more playful, for instance, and more safer than what we have right now. Asset distribution, I think that a lot of the inequality we see today has to do with asymmetry of information. So it's just like this self-feeding feedback loop in which those that have information get more information, those that have the least, they give it all, right? So I think like when you have informational symmetry, right? What you're doing, you're actually you don't need to bring down the current power structures or the wealth or redistribute what exists. You can actually create that, right? You actually all the boats float, right? So it's also a way, like an orthogonal way of approaching how to scale humanity that doesn't rely on conflict, right? Like from the get-go, is saying, hey, this is conflict-free, right? It's protocol, right? And guess what? Reliable protocol. So you don't need to have all these checks and balances and incentives in order to make sure that the programs, the social programs, get executed according to the rules.
I'd like to pose a question about that, which is, so let us assume that the journey will be successful and we can use gravity in space and go warp. Now that we can compose rules and structures to behave and interact that do not require these checks and balances and external enforcement mechanisms, what types of rules and behaviors and systems of interaction do you envision would be possible? Because I imagine they wouldn't be quite the ones we're used to, yeah?
I think that's the whole point of space, right? In which economy essentially, theoretically, is a game, right? It's a game that goes beyond our capacity to comprehend because it's a non-linear system. But I think what we're going to bring is games that also feel like games.
Right.
Different ways of get together, produce together, value things together, right? Instead of relying on whatever authority is telling you we should value, we can define our values, right? Like we become more autonomous, we increase our agency. We can choose to engage or not to engage with certain individuals. We can choose to engage according to certain rules or not to engage with those rules, right? But that's precisely why to be leveraged properly, it needs something like space, right? Which is this meta economy. It's an economy of economies, right? And again, Speco can speak much more to that.
Thank you.
To highlight one point is that, I mean, we have the sense of value already within us, the sense that we might, at one moment, value a privacy of an empty room might be highly valuable, and then 2 hours later, not being valuable at all. So we're working with the practical infinity of different valuations that constantly change, and with no problem at all. And that's actually a much more natural state of value. But in a way, I think we have been made pervert by working in a very, very monotheistic system of value packaging that is, well, we have many currencies, but they're essentially the same structure with very, very little differences. So if we get away from that, which is also kind of getting beyond the idea that launching a new economy is putting up yet another token, and that's the economy. It's range of operations. It's a field rather than one unit, however distributed. So if we get to that, I would expect that our behavior will start to resemble, also in economy, a variety of values and values that change dynamically. Maybe not with quite the speed that we do it when we're in our environments, but much closer to that than what we currently understand value. Because, to be honest, I think we will look like weirdos, hopefully, for people in 50 or even hopefully 30 years who actually might be in a different economy we would look like this sort of some crazy tribe cult that behaves according to some very odd rules. That's what I want. But I don't think it's a utopia. We'll make the world in some ways very problematic, and we'll probably fight maybe in games, but we'll still find ourselves feeling bad at times. It's not a utopia, but it's let's say more interesting place is possible with these constructions like gravity space. That's my 2 cents.
So I think that's it. Thank you guys for listening.
Who's going to close it out next, Tony?
So I'll close it out. If you guys want, it seems like everyone's sort of overlapping here. There's people from other countries that we're just sort of realizing that are sort of overlapping. I think we should probably have a computer with like emails that if people want to give that email. There's a lot sort of happening, and there's a lot of people online as well. I guess we could sort of join your Slack channel, right?
Sure. Yeah.
That's probably the easiest way to do it.
What do people do? How do we do it? Where do we go?
Yes, from Vienna.
You got to come up here because I can't hear you. Yeah, and then like your loudest Vienna voice and real close.
Our chain has their Slack channel open, and then wherever we can find you guys as well.
Yeah. So first of all, am I really playing this
You're
game?
good. You're perfect.
Okay. So I don't have to be as loud as I can. So economicspace.slack.com. You can request for access from our website, economicspace.agency. Second of all, we have a meetup group called meetup.com/economyos. If there is enough demand, which maybe I can survey now, we can possibly push like Chris and John to organize some meetups in New York City too. Like, let me just do a little survey. Who will attend, say, a meetup once a month, for example, on this?
It's upside down world.
Okay, I see you. Okay, so Chris is gonna tell me if you guys are actually gonna turn up. Maybe in the meantime, you want to sign up on the email list so that we can stay in touch on that. And I also want to ask who of you guys here, after listening to the presentation today, could think of like a use case that you might want to work on. Okay, cool. That's what we call the economic space program. And the ones who raise your hand is an econom.
I'm an econom.
So, and he's going to create a legal space. Just so you know, Daza is working at MIT on MIT future legal stuff, future law stuff. So, and there's going to be an AI blockchain conference in MIT on 30th and 31st. And we will be there too.
October. Yeah. October 30 and 31. If you want more economic space agency, come to the Media Lab. You're coming back east. We're going to host them and a whole bunch of other super freaks for blockchain and AI, refactoring the law for a digital age. So come help us.
Yeah. Yeah, I guess that's it. Is there anything else? No, like, of course, we have Facebook as well. We have Twitter accounts. So, yeah, that's it. Thank you.
All right.
And just the last note, on the Slack, there's a channel that's just NYC Meetup. So join the Slack, hop in that channel, let's parties.
Thank you.
There's space.
We can stay back to answer questions.
You don't have to go home. Right. All right. So I think that pretty much wraps it up. Oops, here in New York. This is a much shorter chair than we're used to at law.MIT.edu. So if you want to know more about the conference, it's go to MIT.edu/law. That's right. Not a law school, way better. We're engineering. If you want to know more about Economic Space Agency, it's... What's the website?
Exa.io.
Exa.io. ECSA.io. All right, see you Tuesday at 1 p.m. Eastern Time for Future Law, MIT.